All right, welcome back. What we're looking at now is question 5, the January 2022 CXC Paper 2. It's a cumulative frequency statistics question. It reads the cumulative frequency diagram below shows information about distance, which is in kilometers, that each of 120 students walk to school on a particular day. All right, so we're looking at the cumulative frequency curve here. Let's see what the first question is asking us to do. Here it is. It says down here, let me highlight it. It says, how many students walk at most 1 kilometer to school that day, right? At most would mean 1 kilometer or less, all right? Therefore, what we're going to do is to go to the cumulative frequency curve. We're going to look for 1 kilometer. I'm going to highlight it here. This is our 1 kilometer. So what we want to do is to run a vertical line from the 1.0, and we're going to take that to the curve. So we're following this line here all the way up. We're walking on this line, and right where it touches the cumulative frequency curve, we could use our ruler, and we're going to bring it right across. For example, like this. So we'll take this across there. For now, let's take this off. And we want to read off this number here. Based on what we're looking at in terms of the scale, this is 0, this is 10. And we have actually 5 equal spaces between 10. So basically, we're moving up by 2. So if this is 40 here, then this has to be 36. We're counting by 2. So 20, this is 30, 32, 34, then 36. So basically, we have 36 students at most. All right, so at most would mean that amount or less. So basically, we're saying up to 36 on a particular day. All right, example, we're looking at using the cumulative frequency diagram, determine an estimate of the median. Well, definitely we have to know what the median refers to. The median refers to Q2, which is 50% of the sample. All right, so what's the idea here? What we're going to do is to find 50% of the total sample, and that's not going to give us the answer. So let me show quickly what we're about to look at. We're going to be looking at 50% of whatever the sample is. So in this case, it's 120. 50% will take us to 60. If this is the curve, we're going to follow that 60 with an horizontal line. And when it touches the curve, we stop and then use a vertical line to come down. And then we read off this distance down here. So let's go to the curve and display that idea. All right, so here's the curve. Let's work out, but definitely we all know 50% of 120, but I'm going to put it on the side. So 50 over 100 times 120, you work this out, you will get 60. Here is the 60. I'll highlight it here. This is 60. What we're going to do is to take our ruler and we're going to go across. So let me walk. There it is. And right where it touches the curve there, this is right here. I'll stop. Let me take this off. All right. So it touches it right here at this line here. So what we want to do is to trace this line, come down. Walking it comes down. Right there. All the way down. And we're going to read off this down here. Right. So I want to read off that. So this is my Q2, which is the median. All right. So again, scaling is very important. This is 1.0. This is 1.5. We have 10 equal spaces between this. So simply every 2 of these spaces would be a 0.1. So if I should read, this is 1.1, 1.2, 1.3, 1.4, and you could see 1.5 is landing at the spot that we needed it to be. So this is 1.3 we're reading off there. So the median that to be 1.3 kilometers. The second thing that we want to look at is the ask for the lower quartile. What is the quartile? The lower quartile is what we call Q1. All right, let me just put it right here. Lower quartile is Q1, and it is equal to 25% of the sample. Definitely, we're going to be working out 25% of 120. Well, definitely, this is going to be 30. All right, you work this out, you will get 30. 25% of 120 is 30. So what we're going to do is to go on the curve that we have, based on the scaling that we have, take our ruler, we're going to come at 30, run this horizontal line. All right, so let's go for it. 30 is right here. All right, that's 30. So what I'm going to do is to trace this line until it touches the curve. All right, so let's follow this. So it touches the curve right there. 30 right there. Let me take off this ruler. All right, so 30 touches the curve right here. And then we take this vertical line down. All right, and taking it down, we're going to read off. All right, and when they ask us to use the graph to represent the answers, we have to show these lines. All right, we have to draw these lines to demonstrate our answers. So let us read off. Remember, we just said that two of these little lines here represent, two of these lines down here represent 0.1. So let's see. So this is 0.5, 0.6, 0.7, 0.8, 0.9. So this is landing me at 0.9. Or you could look at it and say, if this is 1.0, 2 spaces before this is 0.9. Doesn't matter how you get it. Bottom line is, we understand that it is 0.9, and that would have been the response that they're looking for here at the lower quartile. So the lower quartile, we get 0.9 kilometers. So the question reads, the interquartile range. See, the word range is coming out. The range refers to the difference between the largest and the smallest quartile. But guess what? Q3 minus Q1 will give us this answer. We definitely have Q1 based on the previous question here with a 0.9, but we need to go and search for Q3. What is Q3? I could just quickly work out Q3 here. Q3 refers to 75% of the sample. So we're talking about 75% of 120, and I'm thinking again, this is going to be 90. Let me just quickly work out. 75% of, well, it's 90 anyway. So it is 90. All right, so 75% of 120 gives us 90. So we're going to find 90 and find that value, and then we come back to see what's going on here. So let us go for the curve one more time, because all the answers are actually from the curve that we're dealing with here. So I'm going to pick off 90. Where is 90? If you look carefully, 90 is halfway between 100 and 80. So it's right here. This is our 90. Let's take off the ruler right now. Take it up there. And we're going to run this until it touches the curve. And then we stop right there. So we stop right as it touches it. All right. So it touches it at this line here, right? So all we're going to do is to run this vertical line down. Take our time with a ruler. And we run this vertical line all the way down. All the way down. Bam. We could see that it is actually one line away from this bright line here. So let us just look carefully to see what is Q3. All right, I forgot to put Q1 on this. This is Q3 up here. And then it's right beside it. Remember though that two of these spaces would have represented 0.1. So we're going between 1.5. So basically where this line came down, we're going between 1.5 and 1.6. All right, so we're halfway between 1.5 and 1.6. Definitely this is 1.55. It's halfway between 1.5 and 1.6. So Q3 is 1.55. All right, so let us now go back to using this answer to finish off what we're doing right here. All right, so interquartile range, Q3 minus Q1. So we're talking about 1.55 minus Q1, which is 0.9. Whatever we get is our interquartile range. So we're talking about 1.55 minus 0.9, and it's 0.65 that we're getting here. So we're getting 0.65 kilometers as our interquartile range. All right, let's go again for another question. So the C part reads, a student is chosen at random. What is the probability that the student walk for more than 1.5 kilometers to school that day? The thing is more than, I will highlight this, more than 1.5. That means we're gonna go over that. Definitely we're gonna have to use our 1.5 as a marker, and then we go over that. So let us see where the 1.5 leads us, all right? Let's go back to the diagram, 1.5. 1.5. All right, let me change our 1.5 right here. All right, so this is 1.5. What we're gonna do, we're gonna go up. We're gonna go up with a bright line. Follow, chase this. I could see that it's gonna stop right here anyways. So we go up with this, 1.5. Using a ruler, we're following 1.5 all the way up. And the moment it touches the curve, which is right here, I'm going to use my ruler to go across. So here's the ruler that I have. I'm having some issues with the ruler, but it definitely goes across here. So I'm going to be walking this across right there, right there. All right. So this is the one line on top of 80. And we're going by 2, 82, 84, 86, 88, 90. We're going by 2. So this is 82 that I'm getting right here, right? So 82. Now the thing is, 82 is not what they want. 82 would have been from 0 going up, which is under 1.5. We're going over 1.5. So let us take a quick look, like we're going over 1.5, over 1.5. So therefore, the difference between the 82 and 120, we're going upwards. So basically, quickly working out this, we're talking about 120 minus the 82 to land us 38. But the question is a probability question. So let's the probability that a student choosing at random walk more than 1.5. We got 38 students to have walked more than 1.5, which means that we're going to say 38 out of how many? It's 120 students. All right, so this is our probability. If we want to cancel this down, you could say 19 over 60 if you want. So it's about the same thing as about 31.666 or 67. We could just say 31.67%. All right, basically as a percentage, because probability can be represented in so many ways. All right, but definitely this is okay. 38 over 120 or 19 over 60 is an acceptable answer for that. Then says, complete the table below and use the information to calculate an estimate of the mean distance walked by the students on that day. All right, so we're asked to find the statistical average, which is what we call the mean. So basically average, I mean, we're going to be looking for. However, information is actually missing from the table that we have. All right, up values from the cumulative frequency and work out the frequency, because we didn't get the cumulative frequency in terms of having values for it, but we are able to work it and do it. But there are, so if I know the values here, this is simply a multiplication, f times x. So I need to find all the frequency, and then from there we could find what we want. Is you add and divide by 2, and we could get the mid values here. This mid value here is 1.75, right? So that's fine. That's 1.75. So we need to find this. So let us go back to the table. So we have a 0.5, 1, 1.5, all the way to 3. Remember, it's a cumulative frequency curve, less than. So we're working with the upper boundaries, basically. So the upper boundaries here can assist me in getting the cumulative frequency at the various places. Remember, we're starting at 12, and then we could do a quick subtraction, as you could see, in order to get the frequency for real. All right, so all right, the upper boundary right here is crucial to what we have. So the upper boundary we have is 0.5. It's going up, then we get a 1, and we get a 1.5. Then we get a 2.0, 2.5, and it goes up to 3. All right, so those are our upper boundaries. If you look in the table, you would have seen all of that. So let us quickly look at using this though, 12 here. All right, so definitely 12. We can work our way by subtracting. Let us see though what we have for each. The cumulative frequency I'm going to put here in this column. All right, so 0.5 went to 12. We could see it here. This is here, 0.5 here. It went to 12 right there. I understand that. Then we have 1. Let us see what 1 went to. 1, oh, we picked off 1 already. 1 as a cumulative frequency went with 36. Quickly, 1.5 is a nice number. And 1.5 went with 82. So we have those already. Follow it, go up to the curve, and then come across. But some of these readings, we actually got them already. 2, let us see where 2 actually took us. 2 is right here. And number 2 right here. It took us all the way up to right here. You have to look carefully. This looks, so this is 110. So this is 112, just 1 over it. So this is 112, 2.5. Let's see where 2.5 took us. All the way up to here, and that's 1 away from the 120. So the 120 is there, we're going up. So it's 1 away from 120. This is 118. And the last one would have to be 120. As you could see, if we subtract the consecutive cumulative frequencies, we'll end up getting the original frequency. For example, 36 minus 12 would give us 36 minus 12 right here. This will give us the 24. And then the 82 minus 36. So 82 minus this 36 here, we're going to land us 46. And 112 minus 82, that's going to land us 30. And 118 minus 112, that's 6. And then 120 minus 118, that gives us 2. All right, so what we need to do is to quickly see what's going on. So the missing values that we have, and 6. All right, so we had a 30 and a 6 that was missing from where we got those. All right, 36 and a 2. All right, we're right there. All right, so we're almost finished. So what we're going to do next is to just multiply these. So we have 1.75 multiplied by 30, and that's 52.5 right here. This is 52.5. And then we have 2.25 multiplied by 6. That is 13.5 that we got here. All right, so what is, all right, which is the mean? It's going to be sigma, which is the sum of the fx divided by the sum of the frequencies. So simply we're going to add up everything there. Let me do a quick check. This landed me 150 there. And my total in terms of frequency from the beginning we sat out, it was actually 120. So I'm dealing with 150 and 120. We're almost there. So over 120. So 150 divided by 120 is going to land us a mean of 1.25. Right? Finally, the mean is 1.25, and that would have helped us to collect that 3 marks there. All right. So thank you for watching. And if you think you have learned, please like, share, and subscribe to DellyMaths Concept.